Hello everyone, welcome to our video lecture in IT Professional Elective 1, which is the Data Scalability and Analytics. So in this video lecture, we will discuss one of the most common computations in the statistics, which are used for predictions of research, and this is the t-test. Okay, I believe this subject or this topic is very important you as an IT student reaching third year and fourth year, because you have subjects like capstone project 1 and 2, and which you have research on predicting sample data or gathered data. Okay, so to begin with, let us define what is a t-test. So the t-test is the one of the inferential statistics. Okay, so when we say inferential statistic, it allows you to make a prediction, okay, by determining or by using those data. Okay, so it is used to determine whether there is a significant difference. Okay, remember that the t-test is used to determine the significant difference between the means of two groups, because mean doesn't provide, or the averaging of group of data doesn't provide full picture when we want to compare the data. Okay, so using the t-test, there are things that we need to consider about regarding assumptions, so the that there must be a normal distribution for both data, the same sample size, and of course similar variance. So when we say variance, referring to the square of standard deviation, and the t-test is very useful for research, or for collecting data around 20 or 30 or 40 items or sample data. Okay, so before we perform the t-test, let us first know, or let us first determine the formula. Okay, about the t-value. We will compute the t-value. So t-value measures the size of the difference relative to the variation in the sample data. So we have here the formula var x1 minus var x2, referring the mean difference of two data sets over the square root of the standard deviation of data set 1 and 2 over the number of data set. Okay, so the total square of standard deviation, which makes result to variance. So this is the t-value formula. Okay, so next is, for example, the research problem. We will determine the significant difference of two groups. Let's say a group of tomato plants in the garden. So you have two gardens, and then the first garden is using a fertilizer. I know, actually, the first garden is not using a fertilizer, and the second garden is not is using, okay, is using a fertilizer. Could be synthetic fertilizer or a natural fertilizer. Okay, so group A is a garden that has a plants of tomatoes that without fertilizer, and group B has tomato plants with fertilizer. So now the assumption now here, the premise now here, is that does group B tomato plants bear fruit more than group A tomato plants? So this so we could do this one, we could compute this one by, we can determine this one by the significant difference using the t-test. Okay, so we have here two data set. So in this data set, the values here referring to the number of fruits. Okay, so the number of fruits. So group A and group B are both tomato garden, and the number of data or here from group A are 5, 6, and so on and so forth, and the number of sample data here from group B 8, 8, 7, 4, and so on and so forth. So the values here are the number of fruits of each plant in the tomato garden. Okay. So next here is now we will, once we have collected the data, we will now compute the t value using the uh, formula. Okay, the t value formula. So we have here the collected data, but first is we have to average the data set. So from using the spreadsheet, you can easily do that by using the function average, not mean, it is the average function. You just highlight the first value to the last value from the first data set. Once computed, you can apply it to the second group B, okay, to the second data set, okay, by simply sliding that crosshair bar below that square to that cell. Then you just slide it, then automatically it will compute it based from the original formula. So averaging is for mean. Next is we have to compute also the standard deviation. Okay, so when we say standard deviation, how spread the number, okay, how spread the number from the data, from the data set. Okay, so standard deviation, simply the formula is equal stdev, then you highlight the first value from the first data set to the first value to, and to the last value of the first data set. Then once computed, you can apply it to the second data set. Okay, and next is the, you have to compute also the variance. Okay, so variance. So when we say variance, simply the square root of standard deviation. So when we say square root, you can easily put equal, then specify the standard deviation. Then in spreadsheet, you use the caret symbol and then specify 2. Once you entered, it will compute the variance. Okay, so and then you can apply the variance also to the second data set. And also you can also, we will determine also the items. Okay, in the item we will use the formula count. Okay, count is, you specify now the number of you can now, you can use, you can slide the cell pointer up to the last pointer from first value to the last value of the first data set. And then once computed, you can apply. In this case, there are in the first data set 15 items, and also with the second data set 15, okay, items. So once we've computed, we can now we can now determine the t value. Okay, so we have here 4.8 minus 6.86 as the mean difference over the square root of the variance 3.02 plus 2.69 divided by both 15 and then 15 first and second data set, the square root of that. So we have here the t value 3.34. Okay, so we have now the t value. So this is now the hypothesis. So in statistics, when we say HO, that is null hypothesis, so meaning there is no statistically significant difference between samples. Okay, so so we have now the t value. We could now compare the t value to the critical value based from the critical value. So where can I find the critical value? From the t-test table. Okay, so the t-test table, you can search that, or you can look for the t-table from Google. There are many table from Google about the t-test table. Okay, so once you look for the t-test table and look for the critical value, then compare it to the t value, then the condition now here is that if the t value is lower, okay, if the t value is lower than the critical value, we would we don't reject, okay, the null hypothesis, okay, meaning there is no statistically significant. Okay, so I will repeat, if the t value is lower than the critical value, there is no statistically significant difference between sample. If another is, if the t value is greater than the critical value, we will reject, okay, we will reject the null hypothesis. There is an alternative hypothesis, this one. So there is, okay, there is a significant difference between sample. So that is the testing of the null hypothesis once we got the t value by don't rejecting or accept or reject. Okay, so we have here the t-test value. So as I've said a while ago, you can look for the t-test table from Google. Okay, there are many t-test table in the Google, and those are standard t-test table. So before we compute or before we look for the critical value, first thing is we need to identify the alpha value or the probability or the significance level. Actually, in statistic, they commonly use the 0.05 p-value. Okay, so the 0.05. Okay, so meaning in inferential statistics, 95% has more chance in would accept, okay, that would accept or has more chance, okay, and 5% we wouldn't accept, okay, for that. So next is we will also, so 0.05 is the significant level or the alpha value, and we will also determine the degree of freedom, DF, degree of freedom. So the degree of freedom is simply the summation of both items from that data sets minus 2, which makes it 28. So again, 15 items from the first data set plus 15 makes it 30 minus 2, that is 28. So we have here the 28 and the 0.05 there as the alpha value. The intersection of that, we have here the critical value, 2.048. So the t-test or the critical value is 2.048. Okay, so we have here the t value is 3.34. The t-test value or the critical value is 2.048. Okay, so go back from the slide from that I discussed a while ago regarding the testing. So the t value is 3.34, and we identify that the critical value is 2.048. So now, is the t value is greater than the critical value? Yes, it is greater. So we will reject. Okay, so we will reject the null hypothesis, meaning there is a significant difference between sample. So the alternative hypothesis will consider. So there is a significant difference between samples. So we can now conclude that there is a statistically significant difference between samples, and fertilizer being utilized in tomato plants can cause greater number of fruits, okay, tomato fruits. Okay, so actually that is the computation of the in determining the t value and also identifying the critical value. Okay, so there are lots of work to do for that matter, and of course in spreadsheet you can easily do that by one function, one formula, and this is the t-test function. Okay, you can easily determine the probability of that matter using that t-test. So t-test, then open parenthesis, the first parameter is the values of the first data set, and second parameter is the values of the second data set. The third parameter or argument is a two-tailed test. Okay, what tail is it? It is a two-tailed test. Okay, meaning in the bell curve distribution, the 0.25 is on the other side, and another 0.25 is in the another side also. Okay, which makes normal distribution. So two-tailed test, and it is an independent sample as a type. Okay, so when you use this one t-test, you can now see the computation of t-test. Then you can compare to the t-test table if the condition of testing can be identified. So this is about the t-test. Okay. So again, this video ends. Our lecture ends now here. I hope you learned something. If you have question, I would be glad to answer it. And you just put comment, or you just ask question to the comment box. So until our next video again. So goodbye.